Hello everyone, I'm Luke. I'm not the person who's going to be presenting today. Deanna will be, but I just wanted to explain to you a little bit about how webinar works. Deanna is going to be presenting on the screen and Vanina will be helping her out to answer all of your questions when you type them in. We have muted all of your microphones so we can't hear what you're saying. Could you actually type something, a question to Vanina so that I can see if you can hear what I'm saying? Just like type yes, I can hear you or something like that. You can hear me? All right, excellent. So she's going to be writing stuff on the screen throughout the PowerPoint, and you're free to send questions to Vanina as the webinar goes along. All you have to do is type it in the question box, just like you have been now. All right, and people can join the webinar at any time, so maybe your other classmates will be joining, but for now, you few are the only ones that are here watching.
Okay, hello. I'm Diana, your instructional assistant for the course, and with many of you I already have been in contact by email. So today is our first online study session, and thank you, Luke, for helping us out setting everything up with the technology. So test one review study session, what we're going to do is I have come up with a bunch of questions that are actually similar to your test one, and we're going to go through them one by one, and like Luke explained earlier, when you have question or you want me to pause or repeat something or still not sure how to do it, please type your question and then Vanina will give me a sign and we will answer your question. So thank you very much, and let's go to the first question. Okay, no panic. I'm just going to have to change my pen. Okay, I guess I'm going to have to get Luke back in here because I can't change the screen to the next slide. Yeah. Okay, now here we go. So I want to be in error so I can go to the next one, and now back to a pen. There we go. And let's just change the color too so everybody can see it much better. Here we go. This is a long division problem, and what we have to do here is we probably should rewrite the problem so it looks more like a long division. We would write the negative 5x first, and then we're using our symbol, and the 10x cubed minus 18x squared minus 7x plus 12 goes under the root. And now to be able to divide these two, you go ahead and you ask yourself this first one, how many times does that fit into the 10x cubed? Okay, so negative 5 fits into 10 negative 2 times, and x fits into here x squared times. And I can check that by multiplying this and this together just to make sure. So negative 2 times negative 5 gives me a positive 10, and x squared times x gives me x cubed. So I chose the right value. Now I have another term here. I'm going to have to multiply this by the positive 4 as well. So negative 2 times positive 4 gives me a negative 8, and x squared, because this one doesn't have an x term, the x squared just comes down. there should be questions already because actually I did a little mistake here. As you noticed, x squared times x should not give me an x squared here, it should give me an x cubed. Because at the end, they all have to be lined up in descending order, which means x to the third power, x to the second power, x to 1 power, you don't see the 1 here, but there is an imaginary 1, and then no x at all, which is x to the 0 power. So that's how I noticed that there was a mistake here. So once I found my two terms, I'm going to multiply both of them by a negative, which should change the signs of both terms. So a negative times a positive 10, now the 10 is negative, and then the negative times a negative 8x squared should be a positive. So once I've changed my signs, I add down, and if I did it correctly, the first term should cancel out. This gives me 0, and then negative 18x squared plus 8x squared is a negative 10x squared. So I'm going to bring down my next term to do the next division. And again, I'm asking myself, how many times does this first term fit into negative 10x squared? The negative 5 fits into negative 10, positive 2 times, and I have x squared here, which means 2 x's. I take out 1, so I should have 1 left on top, and I'm multiplying that back in to make sure I got the right number on top. So 2x times my first term is negative 10 x squared, and then the 2x times the positive 4 is positive 8x. Remember, you have to change your signs by multiplying by a negative sign, which makes the 10 be positive now, and the 8 becomes negative. Okay, I'm ready to add down. The first term cancels out, is 0, and negative 7x minus 8x, this is my new sign here, gives me negative 15x. I have one more term left to bring down, so plus 12 comes down, and now I have to divide my negative 15x by the negative 5x. How many times does this go into here? So the negative 5 goes into negative 15 positive 3, and I have an x. I'm taking out the x, so no more x left on top of here. I multiply it back to see if I got it correct, so 3 times negative 5x should give me negative 15x. You always should get the same number, and then 3 times the 4 is positive 12. Change your signs by multiplying my negative, so now the 15 is positive and the 12 is negative. Adding it all down, this cancels out, and positive 12 minus 12 also cancels out, which means there's no remainder. My remainder is 0. So right here on top, I'm going to rewrite it. That should be my answer for the division problem. And if you printed out the review booklet that I had posted on Blackboard, you will see that there are multiple choice answers. So for you, the correct answer on your package should be A. So before I move on to question 2, I just wanted to make sure that everybody understands how to do long division and there are no questions. Let me look at Vanina real quick. So far, no questions. You can type at any time, and at the end too, and if you still have questions. Let me change to arrow again so I can move to the next slide. This is question number 2, and it asks us, it says, which ordered pair is a solution of the equation? And we are given multiple choices. So these are all points on the coordinate system, and this equation represents a line. So basically what they want to know, which of these points actually is on this line. There are multiple ways to solve this problem. I'm going to choose to just plug in each value. So I'm going to start, sorry, I moved too fast to the next slide. Let me change to pen. I'm going to start with our point under A, and I'm going to plug this in into my equation. This would be my x value, and this is my y value. So my equation is 2x plus y equals -5. And I'm going to plug in right here -5 as my x value. And my y is also -5. And I continue with the equation that I've been given. Now, I'm solving each side individually. I'm not moving nothing around. There are no variables. So 2 times -5 is just -10. And these two signs, I can combine them. A positive times a negative is a -5 equals to -5. Okay, here I still have to combine these two. -10 minus 5. These are both negatives, so I add them and keep the sign, which gives me -15 equals -5. As you can see, these two numbers are not equal, so this doesn't apply, which means the point in A does not lie on our equation, on our line. So this is not a correct answer. I'm going to move to B. I'm going to do the same thing. I'm going to plug in the B point into my equation. So my x value is -4, and my y value, oops, my y value is not y, my y value is 3. Uh-oh, something happened. Now my screen got blank. So give me just a second here. This is what we're dealing with technology. Probably just hit a button by accident. Right here, we are back. Sorry for that. So we plugged in the x value and the y value, and that is all equal. Okay. Sorry for that. I want black ink right here. Okay. So we got our x value and our y value, and that is equal to -5. Solve both sides individually. 2 times -4 is -8 plus 3 equals -5. -8 plus 3 gives me a -5 equals to -5, and right there, this is a true statement. Both sides have the same value, so this is the correct answer. This is the point that actually lies on the line. You can continue and do the other two, but I'm pretty sure there's only going to be one correct answer. So if B wasn't a correct value, if you would get something weird like -15 is equal to -5, which is not true, or any other different numbers, then the point would not lie on the equation. But if you get a true statement, like right here, then this is the correct answer. This is the point that actually lies on the line. Are there any questions for number 2? Okay, then we can move on to question number 3. This question says, write the equation in standard form, and the standard form is given right here. This is a standard form, ax plus by equals c, where a, b, and c just representing numbers. So we are given 2 points and we have to come up with an equation. And at the end, this equation is going to have to be in this form. When I'm giving 2 points, what I can think of is the slope. So I can use my slope to come up with an equation that will go through these 2 points. My slope formula, I hope everybody knows that, is y2 minus y1 over x2 minus x1. And I'm going to label my points. I'm going to call this my first point, so I'm going to put a little subscript of 1. This is my first y, so a subscript of 1, and this is my second point, so 2, and my second y, so 2. But you can label them in any order, just make sure you stick with that labeling that you do in the beginning. I'm going to plug in my values. My y2 is 3. From the equation I got a negative, and then my y1 value is also negative. I cannot forget about that, negative. And over x2, which is 0 minus from the formula, and I have a negative x1 value. I'm solving the top and the bottom individually, and then I can see if I have to reduce that as a fraction. So 3 minus minus, that will be a plus, which means 3 plus 2 is 5. And 0, this also becomes a plus. Negative times negative is a plus. 0 plus 4 is just 4. Okay, so I got a fraction. I always have to check if I can reduce or simplify fractions. In this case, it's fine to leave it like that. You cannot reduce it. And even if it's an improper fraction as a slope, it's okay to have an improper fraction. Okay. Once you found your slope, we can use another formula, and I hope you know this one. This one is called the point slope formula. Y minus y1 equals m times x minus x1. We can use this formula to help us come up with the equation in standard form, because we have our slope now right here, and we are giving 2 points, but we only need 1 point for our point slope formula, so we should be able to solve this. From the formula y minus my y1, and I can choose either one of these points. I'm going to choose this as my point, even though it says 2, but I'm going to choose this one because I like these numbers better. They are positive numbers and they seem smaller, so I'm going to plug in this one as my point. You could have also used the first one. You should get the same answer. So my y1 value, in this case my y value, would be 3, and then I found my slope, which is 5 over 4 x from the formula, and I'm putting in my x value now from the point that I chose, which is 0. And now I'm simplifying my equation. So I'm getting rid of this parentheses by using distributive property. I'm going to distribute the fraction to those 2 values, bringing down the first part of the equation, and 5 over 4 times x is just 5 over 4x, and 5 over 4 times 0, it's basically 0. I don't really need it. Okay, so if you look at the standard form, it has the x and the y value on the left side and the constant, the number, on the right side. So I'm going to move my terms around that it looks just like the equation in standard form. I'm going to subtract my 5 over 4 x from both sides. And remember, there are multiple ways to solve equations, so I might not use, the one that you practiced or you would choose, But as long as the answer is correct, your way is also right. And the 3, I want to move it to the right side, so I'm going to add 3 to both sides. Okay, on this side, the fraction would cancel out, and on this side, the 3 will cancel out. These are not like terms, I cannot combine them, so I'm going to write my x term first. And then my y is positive. And on this side, I should get a positive 3. So if I look at my answer sheet right now, because remember you are given it in a multiple choice form, I quite don't see my answer yet, and that is because usually in standard form they don't like you to keep fractions. So we have to get rid of the fractions, and to do that we can multiply by the denominator. In this case, my denominator of the equation is 4. So what I'm going to do is I'm going to multiply the entire equation by 4. And usually they also don't like negatives, so I'm going to get rid of this negative, and I'm going to multiply by a negative 4. So negative 4 on this first term, negative times negative 4 on the second term, and negative 4 on the last term. Whatever you do to the equation, you have to do it to each individual part, and the equality is still valid. Okay, so multiplying fractions, I can also make this a fraction by putting that over 1, and remember it's not subtraction, it's multiplication. And I can cross simplify before I multiply, because I see 2 common factors right here, the 4 and the 4. 4 goes into 4 one time, and 4 goes into 4 one time. Then I straight multiply the leftover number, so I have a negative 1 times a negative 5, leaves me with a positive 5x, and then the denominator is basically gone because 1 times 1 is just 1, and 5 over 1 is the same as 5. Then right here I'm multiplying my negative 4 times y, so I'm ending up with a negative 4y. And over here I'm multiplying the 4 times the 3, the negative 4 times 3, and that gives me negative 12. So now I have no more fractions, and my x term is positive, and if I look at the answer sheet now, I see that this answer would be a C, letter C. I see there might be some question because Vanina is typing away. Are there any questions, Vanina? Okay, she's actually answered them. Thank you, Vanina. Okay, so I guess we can move to the next slide. Let me switch my pen. This is question number 4, graphing. And it says graph the inequality. So if we, no matter if we want to graph an inequality or an equation, to do that, I like my equation to be in slope-intercept form. And this should already sound familiar to you guys. Y equals mx plus b. This is my slope-intercept form. And in this form, it's easier for me to graph. So right now, it's not solved for y, so my goal is I'm going to solve for y as an inequality. So let me write it here. Greater than or equal to negative 5. Don't worry about the inequality sign, just treat it like an equal sign, and the only additional rule you guys will have to remember is when you divide or multiply by a negative number, that's when the sign flips. Okay, but as of right now we haven't multiplied or divided yet. So to get y by itself, I'm going to move the x to the other side, so subtracting x from both sides. On this side is gone, I'm left with 4y greater than or equal to, and then these are not like terms. I write them next to each other, and because mx plus b, I'm going to write my x term first, and then my b, my y-intercept. Okay, y is still not by itself. I have to get rid of the 4, so I'm dividing by 4. And this would be the step that determines if the sign flips. I have to divide each term by 4. The 4 is positive, so nothing happens to my sign. But if this had been a negative number, then the sign would go into the opposite direction. So instead of showing in this direction, it would be less than or equal to. But in our example, we do not have, we don't divide by a negative number. But be careful on the test. You never know which question you're going to get. So after dividing by 4, this one is just 1y or y. My sign did not change. And over here I can rewrite this fraction by putting a 1 in front of the x, so 1/4 x. And I check if I can simplify or reduce. Nothing. I just leave it like that. Okay. So now I have my inequality in the slope-intercept form. And I don't like my b to be a fraction. I don't really know where this value is on the graph. I can convert that into a decimal or into a whole number. -5/4. I hope you guys know how to convert improper fractions into mixed numbers. So my -5/4 would be 1 and 1/4. Please let me know if you guys don't know how to do this part, but I'm assuming that everybody knows how to convert improper fractions into mixed numbers. But at your level, you're also allowed to use calculators. You can might as well type it in and use the decimal instead. So let me just rewrite my problem. And I got a -1 and 1/4. And now I can graph it. I'm going to start with my y-intercept. This is my y-intercept, my b. So on the y-axis, which is this, and this is my x-axis, on the y-axis I'm looking for the point -1 and 1/4. So 1 is right here and 1/4 is approximately right here. This is where the line will be crossing the y-axis. And from there, I am going to count my slope. My slope is m, which is this number right here, the -1/4. Rise over run. Rise means up or down, and run means right or left. And if my slope is negative, I only can use the negative one time, either for the top number or for the bottom number, but not for both. I'm going to use it for my top number, for my numerator. So I'm going to start off at my y-intercept with going down for the negative, down 1. So I'm here right now. And then 4 as my run. My 4 is positive because I already used the negative sign, so I'm going to the right. 4 units to the right. 1, 2, 3, and 4. So right there is my second point of my line. I had my intercept and my second point. If I connect them, I have my line. I can continue with my slope to make a couple of more points. If I have problems graphing it, it was 1 down, 1, 2, 3, 4 to the right. And all these should be on the same line. And remember the inequality sign. Whenever the inequality sign has this bar, the bar in the bottom, you have lines, And whenever you just have the inequality sign greater than or less than, you should have a dotted line, which means the points on the line are not included. But in our case, we had the big equal bar underneath inequality sign, so we have a straight line. So to be able to graph the inequality, we going back to our original problem right here, and at our y-intercept right here, we're going to ask ourselves, where are the numbers? You see how the symbol says greater than or equal to? So where are the numbers that are greater than or equal to the y values on this line? And the numbers that are greater than would be above. So all this above shaded. If you look at your packet and you compare the 4 graphs that you are given there, you see that B is the only one that has the same y-intercept, and that is also shaded above. So the correct answer for problem number 4 would be B. Let me know if you have any questions on graphing inequalities. Ranina, you answered all the questions already? Oh, that's good. Ranina is a real help today, so I can concentrate just on the screen, because as you may see, it's not as easy as it looks. Let me change it back to my pen. Okay, this is problem number 5. It says, find an equation of the line and write the equation in slope-intercept form. So in the previous problem, we already used slope-intercept form. You should know what that is. Y equals mx plus b. And in this problem, we are given the slope and a point. So to find an equation, if we are given a slope and a point, we can use the equation that we used before, point-slope form, which was y minus y1 equals m, open parentheses, x minus x1. And we can use this equation to convert it so it looks like in slope-intercept form. Here's my x value and my y value. Just plug in everything you know. This is given from the equation. My y value is 5. Then I'm given my slope, which is 2. X is from the formula, and my x value is 8. So solving for y, I'm going to use distributive property right here. Left side stays the same for right now. 2 times x is just 2x, and 2 times negative 8 is negative 16. I'm gonna get y by itself, add 5 to both sides. This side, it's gone. Y is by itself. 2x comes down, and negative 16 plus 5 should be a negative 11. Okay, so our equation is in slope-intercept form. We used our slope and the point, and this is your answer. If you look at your packet, this represents answer choice C. Questions on number 5? Okay, this is question number 6. It says find the intercepts of the given equation. So we are given an equation. It doesn't matter in which form it is. Whenever they're asking you guys to find the intercepts, what you do is you're plugging in 0 for the either for x when you're looking for the y-intercept, or for y when you're looking for the x-intercept. So let's start looking for the x-intercept first, which means we are going to plug in when we're writing it as a point, we are looking for our x right here, so we will be plugging in a 0 for y. This is our x value, y value. So in the equation given, we're looking for x-intercept and we're plugging in a 0 for the y value. Right here, -6 times 0, it's just 0, it's gone, which leaves us with 3x equals 7. And getting x by itself, divide by 3 on both sides. This side is gone, it's just 1x or x, and 7 over 3, you cannot simplify it, and I'm pretty sure it's fine to keep it as an improper fraction. Okay, we found our x value, we still need our y-intercept. So our x-intercept is, we can fill it in here now, 7 over 3, and we're going to do the same thing now with our y-intercept. But in this case, instead of plugging in a 0 for y, we are going to plug in a 0 for x because we are looking for y. So 3x for x, 0, minus 6y equals 7. Solve for y. 3 times 0, it's gone. It's just 0. -6y comes down equals 7. To get y by itself, divide both sides by -6. This one is just 1y or y. And 7 over -6, you cannot reduce that, just leave it like that. This is our y value for the intercept. And if you look at your packet, these two intercepts should represent B. Okay, Vanina is giving me a sign that there's a question. Yeah. When it's going to be posted and how it's going to be posted, I will give that information at the end. So let us just move on with the math questions first, and then I will give you information about the test, the location, the time, and all those kind of questions. Thank you, Vanina. Okay, so no questions to number 6. Let's move on because we only have 2 hours available for this session. This is question number 7. Number 7 asks us to graph the equation. Okay, and it's already in slope-intercept form, in the form y equals mx plus b. So I don't have to move nothing around. I need my graph though. I know you guys are probably in your packet given. This is my y-axis, my x-axis. And when I'm graphing an equation in the slope-intercept form, I'm starting with my b. My b is -8. And then I'm counting my slope. In this equation, my slope is 4. So start on the y-axis at -8. Right here, this is where the line going to cross the y-axis. That's why it's called y-intercept. And from there, count your slope. You can make it a fraction. So you have your rise and your run. Remember, rise was up and down. So from here, go 4 up because it's a +4, and then a +1, so 1 to the right. I should make my tally marks here. I also should label them. And I got my y-intercept. I got another point. With 2 points, you'll be able to graph a line. Should use a straight edge probably. I cannot do this here. And this would be the graph of the equation given. So compared with your packet, make sure the line goes in the right direction, it crosses at the right intercept. You can count the slope on the packets, and you should see that the only correct answer that matches the graph that I did is A. Questions on this kind of material? Okay, let's move on to question number 8. This question says, write the equation of the line in slope-intercept form, y equals mx plus b. We already know that from the previous problems. And this equation goes through this point and is parallel to this equation. So whenever we hear the word parallel, we should know that parallel lines have the same slope. And also, if this problem had said perpendicular, we should know that perpendicular lines have opposite reciprocal slopes. But in this case, it's parallel. We need to know the slope. But in this form, we cannot identify the slope. So the first thing we should do is put it into the slope-intercept form. 6x plus 5y equals 14. Slope-intercept form means solve for y. So getting y by itself, subtract 6x from both sides. Write the x term first, and then plus 14. Divide by 5. So y equals, again, we cannot simplify this fraction, so it could stay like this. And 14 over 5. But we don't really care about the y-intercept. The only thing we are interested in is the slope, which is right here. Bless you, Vanina. So we found our slope of the equation that we want to create, which is negative 6 over 5. And now we can use our point slope form because we are given a point from our new equation and said to have the same slope. We can use our point slope form to come up with the equation. This was the y minus y1 equals mx minus x1, and we plug in all the values we know. Our y value is right here, our x value. So minus from the equation, negative 5 is our y, negative 6 over 5 is our slope, x minus, and the x value is 4. So simplifying both sides of the equation, y negative times negative is a positive 5. And here distributing to both terms inside, negative 6/5 times x, negative 6/5 x. Negative times negative is a positive, and you can make it a fraction if that helps you. I cannot cross-simplify nothing, so I'm just straight multiplying 6 times 4, which is 24, and 5 times 1 is just 5. Okay, my y is still not by itself, so I have to add 5 to both sides of the equation. And this side is gone, equals, and I intentionally put it under here because these are like terms. I cannot add the 5 to the x term. They are not like terms. And when I'm adding fractions, I also need the same common denominators. So this is my first fraction, and I'm supposed to add 5. I can make it a fraction as well. My least common denominator is 5, so I'm multiplying denominator and numerator by 5. I'm just rewriting my problem. And my new equivalent fraction with the same denominator is 25 over 5. Okay. Now, I actually can add the numerators. I have a slight feeling that there is a sign mistake, but did anybody notice anything? Vanina, help me out here.
The student asked me if it's the add or subtract flag.
Right. You see, I noticed that something is going wrong right here. We are not supposed to add. That's very good. Thank you. We are supposed to do the opposite to be able to cancel them out. So subtract 5 from both sides. Let me change the color. So right here, you're supposed to subtract. Then this would be subtracting, and this would be subtracting. Thank you very much. So we actually subtracting the two fractions. First one stays the same, and positive 24 minus 25 gives us a negative 1/5. And if you look at your packet, this reflects answer choice B. Okay, any questions? Moving on to question number 9. This one says multiply. So when we have two binomials and we're multiplying, we're using the FOIL method. Multiply the first times the first. X times x is x squared. The first times the second, x times 4 is 4x. Second times first, 2 times x is 2x. And second times last, 2 times 4 is 8. Usually when you have problems like that, in the middle there's going to be two like terms, so combine them. 4x plus 2x, 6x, and plus 8. There's nothing else we can simplify or combine, so this is your answer for question number 9. I see Vanina answering questions, so I'm moving on to slide number 10. This one also asks us to multiply, but now we having, let me change to pen. We have to use the same method, FOIL. So we're doing the same thing. First times first. 7 times 9 is 63. And x times x is x squared. And then first times second. So 7x times negative 11 is negative 77x. 6 times 9x, so second times first, is a positive 54x. And then second times last, a positive times a negative is a negative, and 6 times 11 is 66. Again, like I said, usually there are two like terms in the middle, so you will have to combine them. And after combining these two, negative 77 plus 54, you probably can use your calculator, or you can do it the old school way by just subtracting, write the bigger number on top, smaller number in the bottom, and keep the sign of the larger number. So in our original problem, the larger number was negative, so our answer should be negative. And 7 take away 4, you got 3. 7 take away 5, you got 2. So negative 23x minus 66. We cannot simplify anything else, so this should be our final answer. And in your packet, this is answer choice A. Question number 11, multiply. So now instead of using the FOIL method, we only have one number outside. We can use distributive property by multiplying the front number to each term inside the parentheses. So 4z times 2z squared, 4 times 2 is 8, 1z times the z to the second power here gives me a total of z to the third. 4z times 3z, 12z squared, and 4z times a negative 7 is negative 28z. Okay, checking if there's anything we can simplify. These are not like terms. They all have the same variable but different exponents, so this should be it. And if you look at the packet, there should be an answer choice D. Okay. This is question number 12. It also asks us to multiply, but this time, if you notice, there's no addition or subtraction going on, so we're going to use the rules for exponents in this case. First step, we should just multiply the numbers together. The negative 4 times positive 8, which is negative 32. And then we can multiply the like variables together. So I got an x here and an x here. When I'm multiplying variables, I basically add the exponents. So 3 plus 6 is 9. And then I'm going to combine my two y's. And here, if it helps me, there's an imaginary 1 on the y. So again, when you're multiplying variables, you add the exponents. So y to the 5th power. There's nothing else I can combine, so this is my final answer. And question number 12 looks like this is answer choice D. Are there any questions on exponents? This is 13, so this is even a shorter version of multiplying variables with exponents, and I just explained to you guys already, when you're multiplying variables, you add the exponents. So this is nothing else than x2 plus the 6 on top, which gives you x to the 8. And it is answer choice B. Question number 14. So here we have to apply not only the rules for multiplying with exponents, also for division. We got the 0 rule and a outside power. Okay, so where are we going to start? Inside the parentheses, I would start right here with the 0 power, because anything to the 0 power is just 1. And be careful, there's two different ways. For example, it could be like this, 3 times c to the 0 power, or 3 to the 0 power. Both of them would give you a different answer. And the 0, the exponent only applies what's immediately in front. So in this case, it's just the c. The 3 stays, and only the c to the 0 power becomes a 1. And in the second case, now the 0 applies to everything that is inside the parentheses. So in this case, everything is becoming 1. So these are the different versions of it. In this case, the 0 only applies to the c, so only the c becomes a 1. And what else we can do? Inside the parentheses, we cannot simplify the fraction. We don't have like variables, so we can move to the outside power now, which is straight multiplying. So 2 to the third power, and then when I have variables, I just multiply. A, 4 times 3 is 12. B, 4 times 3 is also 12. And in the bottom, I got left a 3 to the third power. Okay, so now I can do a little side work or use my calculator. 2 to the third power is nothing else than 2 times 2 times 2, and I like to write it like that because remember there are different rules for exponents and for numbers. Do not mix them up. 2 times 2 times 2 is 8, and the same for 3 to the third power is just 3 times by itself, which gives me 27. So my answer for this problem should be 8, A12, B12, and 27 in the bottom. If I wasn't able to simplify the fractions in this step, there should not be a reason why these two can be simplified. So I don't have to check for simplifying fractions if there was nothing to simplify in the beginning. If I look at my packet, this is answer choice D. Okay, division with exponents. Let's see what we got next. The next question is another long division. And before we start, we can rewrite it. We're writing our divisor in the front and our dividend inside. We make sure that the variables are in descending order and none of them is missing, which means the largest one is x to the second power, then should be 1. Remember there's an imaginary 1, and then none. So this is good. If by any chance you're missing 1, you will have to add it in by adding whatever it's supposed to be. For example, if the x term was missing, you're just adding in a 0x term to fill in this space. But in our case, they are all in descending order, so we don't have to add in nothing. We're going to start with the first term. How many times does the x go into x squared? So x times x is x squared, and also multiplying it back to the 5. X times 5 is 5x. Remember, you have to multiply by a negative sign, which changes all the signs inside. First term should always cancel out, and then positive 3x minus 5x is negative 2x. Bringing down the next term and starting again from the beginning, how many times does the x go into negative 2x? It goes in there negative 2 times. And check by multiplying back in, negative 2 times x should be exactly the same. And negative 2 times the positive 5 is negative 10. Changing the signs by multiplying by a negative, this becomes positive, positive, and as I can see, both of these terms cancel out. Again, I have a remainder of 0. My answer is x minus 2, and that should be answer choice B. in your study packet. Okay, I see no questions on long division. Let's move on to question number 16. You might haven't done absolute values yet, but this will be on your test. So let me just go over it, and hopefully after you finished the missing sections you can come back, or if you have questions. Alright, so if you have absolute value, the absolute value is nothing else than the distance from 0 on the number line. So absolute value should always be positive, just so far. And the way that you're solving absolute value equations is that there are going to be two answers, a positive and a negative. So for example, if I forgot to change my arrow to a pen, so sorry for that. If you call this Z and you call this W, just simplicity, to get an answer you're going to have a positive version, which means Z equals W, and you're going to have a negative version where Z equals negative W. So instead of using variables, using the actual values, we're going to have a positive, just writing it down, taking off the absolute value bars. And then we're also going to have a negative version of it by leaving the left side alone and multiplying the right side by a negative. Okay, I'm getting slightly out of the border here. I hope you still can see it. So let's just start with the left equation. These are two totally independent equations. So with the left side now solving for the unknown variable, which is x, I'm gonna subtract my 10x from both sides. This gives me a negative 16x and adding 10 to both sides. Okay. Leaves me with 8 on the right side. Last step, to get x by itself, divide by a negative 16. So x, and you can, this time you can simplify the fraction. They both have a common factor of 8. So 1 over 2, negative 1/2. This will be our first answer, but like I said, with absolute values you usually get two answers. And we have to do the same thing again on the right side with the equation where we had to add the negative sign. So distribute the negative sign inside here. Negative and negative gives me a positive 2. Negative times a positive 10 is a negative 10x. And then solving for x. So add 10x to both sides. Negative 16x minus 10 equals 2. This cancels out. Adding 10 to both sides. Leaves me with 12. Dividing by a negative 16 on both sides. And at the end, reducing the fraction, we can simplify that. Both of these numbers share a common factor of 2. So this will be 6 over 8. And then again, I chose some factor but not the right one. This is still simplifiable. They share another factor of 2, so I can go even further. 6 divided by 2 is 3, 8 divided by 2 is 4, so negative 4 over 3. Now I got my 2 answers right here, and usually you write this in the form with the curly braces. So one of our answers was negative 2, comma, and our second answer was negative 3. Oh, gosh. Okay, wait a second. There must be somewhere a mistake again. And I see Vanina typing, so help me out here. Vanina, you didn't figure it out yet? Okay, so on this side, probably reducing a fraction, and that's why you guys are so lucky that you can use a calculator. So those kind of things should not happen. Let me see. We subtracted, so we got this is still okay. Then this is 12, and then we divided here by a negative 16. So so Vanina, did you get it? Okay, so you see, not you guys just make mistakes. Could happen to anybody. If this was the correct answer, let's check in the packet if this is even an answer choice. This is question 16. No, it's not an answer choice, so we did make a mistake. Uh-oh, again with the switching signs, so we added a 10 and I did subtract 10. There we go. Let me change my color. Who found it? A student or you, Vanina? Thanks to Vanina. Okay. I hope somebody else noticed. Okay, so we're supposed to do the same on both sides. So right here we were supposed to add. That's where the mistake happened. And then when we add 10, we are not getting negative 16. We should get a positive, so this is wrong. We should have gotten a positive 4. Okay, so this is not 16. This is a positive 4 on top, and we're dividing by a positive 4 on both sides. And now 12 over 4, you can reduce that. And that the 4 goes into 12 3 times. So our x value is actually 3. And now we should be able to find our answer in the packet. And it's answer choice 16, answer choice A. Okay. Anybody has question to this problem? Then let's move on to question number 17, which is another multiply problem. And again, we should be using foiling for this type of problem if we're multiplying two binomials. So first times first, 2x times 5x, 10x squared, 2x times 7y 14xy negative 9y times 5x is negative 45 y xy, and second times last, negative 9y times positive 7y is negative 63 y squared. In the middle you see these two terms, they are like terms, so we have to combine them. 14 minus 45, you guys are allowed to use calculators, but I hope some of you might know that in your head. Minus 31xy minus 63y squared. So there's nothing else we can combine. This should be your final answer. And if you look in your packet, that's B. Okay. Question number 18. Another absolute value problem. So in the previous problem we had the two absolute value bars and there was no extra numbers involved. In this case we only have one absolute value and there are numbers involved. The first step is get the absolute value all by itself. So right here this has to be by itself, bring everything to the other side. Let's start by subtracting 8 and make sure I'm writing the same signs on both sides of the equation. And this side cancels out. (23) minus 8 should be a positive 15. And then right here this is multiplication, so to get rid of this 8 on this side we can divide on both sides by 8. And this is not reducible, so 15 over 8 is fine. Now as you can see the absolute value is by itself. We can use the property that we're going to get two answers, a positive and a negative value of it. So one of our answers is going to be a negative 15 over 8, and one of our answers is going to be the positive 15 over 8. So let me give you a second, just in case there are questions on absolute values, because I know some of you might not have watched the sections yet. And let's take a look at question number 19. This question asks us to graph the linear equation. Remember, my preferred method is using the slope-intercept form to graph, but there are multiple other methods like creating a table or finding the intercepts that do the same thing, that will help you to graph a line. But I am going to use the y equals mx plus b method. So I will have to solve my equation for y, getting y by itself, moving the x, term first, and then my constant, dividing by 2, and my equation in slope-intercept form should be this. Now I know my b, my y-intercept, which is the last number, negative 1/2, and I know my slope, which is m, negative 1/2 as well. I start with my y-intercept. Again, if you are not comfortable with fractions, you can convert this into a decimal. This is the same as negative 0.5. So on the y-axis, negative 0.5, if this is 1, this should be a negative 1/2 right here. This is where my line going to cross the y-axis, and from there counting my slope, rise over run. If you remember in the previous problem, I used my negative for the top number. In this case, I'm going to use it for the bottom number, just to show you guys that you will get the same answer no matter what you do. So in this case, my 1 is positive. I rise 1, and then my run is negative, negative 2 to the left, 1, 2, so right here. 1 rise, negative 2, run. And I can, when I use the negative sign for the top number, I'm supposed to go down 1 and 1, 2 to the right. So as you can tell, all these points are on the same line. You can look in your packet and you will see that the only line that looks exactly like mine and goes through the same points is A. Okay. Next question is question number 20. This is a problem with exponents. And we already had one previously where we was talking about the rules of dividing exponents. So when I'm looking at this problem, first thing I would do is deal with the numbers first. This is nothing else as a fraction, 24/3, and see if you can simplify that. 24 and 3 share a common factor of 3. So I can reduce this to just 8, because the 3 goes 8 times into 24. Then I have an m on top and an m in the bottom, and it's division. So when you're dividing exponents, you subtract 5 minus 4, which gives me just 1 is a positive answer, so I should write my answer on top, m to the 1 power, or I can leave out the 1. And then I got my ends here, and they are also divided, so I subtract 7 minus 5, and that gives me also a positive answer, so it should go on top, n to the 2nd power. When you do the subtraction and you would have gotten a negative answer, you can write that in the denominator in the bottom, but keep it positive. But in this case, I'm all done. I simplified everything. My final answer should be 8m n to the 2nd power. And this is answer choice B. Question number 21. Solve the equation for y. Okay, we already solved a few previous equations for a particular variable, so this shouldn't be that hard. Our y is right here, so let's move this term over. The hardest part is writing the same sign on both sides of the equation. So on this side it cancels out. I got 5y left, and on this side 7x minus 4x leaves me with 3x plus 6. Divide by 5 to get y by itself, and then see if you can simplify the fractions. Nope, doesn't look like. So our final answer should be this. And in your packet, that's choice B. Okay. We're almost there. There are 25 questions on your test 1. So this is question number 22. And this one says, determine if the lines are parallel, perpendicular, or neither. in one of the previous problems, I mentioned to you guys that parallel lines have the property that their slopes are exactly the same. Perpendicular line have the property that their slopes are opposite reciprocals, and neither would be all the rest. So let's see if these lines are parallel, perpendicular, or neither. We have to compare their slopes, and neither one of them tells us what's their slope is. So we have to put them into the slope-intercept form. I forgot to change my pen to writing. Okay, now into the slope-intercept form, y equals mx plus b, and starting with the first one, solving for y. So right here is y, moving the 12x to the other side by doing the opposite. $12x plus 16, then getting y by itself, dividing by 4 each term, and simplifying the fractions if I can. In this case, this leaves me with 3x, and 16 over 4 is just 4. So my slope of this first equation is -3. Now we can solve equation number 2 to see what the slope is and to be able to compare their slopes. So subtracting 18x from both sides, and dividing by 6, that leaves us with -3x, and we don't even have to worry about the last part anymore because we're only concerned about the slope. Right here is our slope, -3, and if you compare both of them, you see they are exactly the same. So that means that the slopes of the two lines are parallel. Okay, just for reference, if they had been perpendicular, then one of them would have been -3 and the other one would have been, the opposite of negative is positive, so positive, and then the reciprocal of 3 is 1/3. Just for you to know what means perpendicular lines. Okay, going to the next question, which is 23. This one says, find the equation of the line that has the given properties. Write the equation in standard form. Ax plus by equals c. So this is the equation in standard form. And this equation must contain the point 7, 8 and is perpendicular to that line. So now we actually have to find the perpendicular slope to be able to write an equation. So our equation is 7x plus 8y equals -113, and we need it in the slope-intercept form to be able to know what the slope is. So let's solve for y, adding 7x to both sides. (7x minus 113) dividing by 8, dividing by 8, dividing by 8. So my slope is 7/8. I cannot reduce this fraction, and I don't want to torture myself. I don't really need to know what this means, what this is going to give me. I'm only concerned about my slope when asked to find the perpendicular slope. So perpendicular is opposite reciprocal. The opposite of positive would be a negative, And the reciprocal of 7 over 8, switch the numbers, is 8 over 7. So knowing my slope, being given my point, I can use the point slope form, y minus y1 equals mx minus x. We have quite used today. Plugging everything in, my y1 value is right here and my x value. So this is 8 equals my slope right here, negative 8 over 7, x minus, and then my x value is 7. Okay, solving it for standard form, let's first get rid of the parentheses. Distribute negative 8 over 7x, and negative 8 over 7 times negative 7, I can make this a fraction, and it would be able to cross simplify right here. 7 goes into 7 one time, 7 goes into 7 one time, and I'm left with negative times negative is a positive, 8 over 1, or just 8. In standard form, right here, I need my variables on the left and my constants on the right. So I'm going to move my x term over by doing the opposite. Okay, on this side cancels out, and I got 8 over 7x plus y minus 8, and 8 left on this side. Adding 8 to both sides, 8 over 7x plus y equals, this can it's going to become 16. Okay, I'm running out of space here. This looks like standard form, but it's not yet incomplete because we have a fraction right here. Remember, to get rid of the fraction, multiply each term by the denominator, so by 7. And the first one is 7, and the 7 will cancel out right over here. So we are left with 8x. And then y times 7 is plus 7y. And 16 times 7 is 112. Okay, now it looks like standard form, but if you look at your packet, you might notice that you still can find it. Two of the options start with 8x, but they are negative. What we can do is we can multiply the entire equation by a negative sign. So multiplying by a negative just changes all the signs inside. Negative 8x, then negative times a positive, negative 7y, and negative 112. So now we made it work, and it looks exactly like our answer choices, and this should be answer choice D right here. Okay, so we did problem 23. We got 2 more to go, almost there. And this one asks us to find the slope of a line parallel to the line containing the points. So parallel means same slope. We are given 2 points, so we should use the slope formula. y2, we have used it already today, minus y1, x2 minus x1. Labeling my points and then plugging in these values into the formula. So y2 is right here, -7 minus, and then -1 over x2, which is 2 minus from the formula, and just 1. -7 minus minus, this would be a plus. So minus -7 plus 1, -6, and 2 minus 1, just 1, which simplifies to -6. Okay, if we found our slope, it says parallel, so we can use the slope as is. And with the given information, point, slope, the only thing I can think of to write an equation of a line. Oh, we're not supposed to find an equation of the line. This is enough. The slope is enough. So this should be your answer, but if you should have, if they had asked you to find the equation of the line, you would have used the point slope form because you're given the slope and you have a point to find the equation. But in this question, the slope of a parallel line is enough. The slope of the new line is also -6. And this is answer choice B. Okay, our last question. Question number 25. This one again deals with the rules for exponents. We have a, I call the superpower outside because an exponent is raised to another power, and there's nothing we can simplify inside, so we just distributing the outside exponent to everything inside. -3 to the 5th power, then x, remember a power raised to another power, you multiply, 2 times 5 is 10, and then y, right now it has an imaginary exponent of 1, so 1 times 5 is just 5. In this problem, they do not need you to do the exponent of 5, -3 raised to the 5th power. This is fine. The answer choices show it to you like that, but if you would, it would give you a -243. But in your case, this would be the final answer choice, which is A. Okay, this was our first online study session, so there were some hiccups. I apologize for some mistakes I made, but thankfully some of you noticed, and my helper here in the room. So I said I was going to give you some information about the study session and about your first test. So here's the info. The test one has to be taken in the Osceola Campus Testing Center. You can find it on Blackboard. It is password protected, so only the testing center has the password. The time that the test will be available is from Friday the 30th to the next week Friday, the 6th, all the way until 5 p.m. When I say 5 p.m., I don't mean show up there at 5 p.m. because if you notice the hours of operation in the bottom, the testing center actually closes at 5 p.m. So you will have to be there 2 hours before that time. Otherwise, they won't let you take it. Then things that you are allowed to bring and that you need to know when you're going to take your test in the testing center, you're allowed to have a graphing calculator, not an Inspire, the calculator that was mentioned in your syllabus. I believe it's the 83 and 84. Obviously, bring a pencil, unless you can do everything in your head. Paper will be provided to you if you need some. You must have a VID or a valid photo ID. And when you arrive at the testing center, they might ask you for the CRN and your course. So the CRN for your course is 22524. You are taking intermediate algebra, which is the MAT 1033C. And my name, I'm the one that submitted the testing center referral, so they probably have my name in the information in the email. It's instructional assistant Diana Budach. And in the bottom I wrote the hours of operation on the testing center, and all this information can also be found on Blackboard. I will download this video to YouTube, and I will post the link in Blackboard on the announcement for you to be able to watch it, or for students that weren't able to make it because they have other responsibilities, and then they can watch it over the weekend. You can email me or send me screenshots of additional problems that you have. I will be still online for a little longer if you have problems or want to type in questions. Other than that, I wish you good luck, and hopefully I hear from you in your class and during the next study session. Thank you so much for joining, and have a good afternoon. Okay, I have a question here. If you can use a TI-84 plus calculator, I believe, check your syllabus, please. I don't want to give you any wrong information. Whatever is stated in the syllabus, I know Dr. Bedoni put that in the syllabus, that's the calculator that you're allowed to use. Anything below is fine. Anything above the calculator mentioned in the syllabus will not be allowed in the testing center. Okay, there's another question about the building and room number of the Osceola Campus Testing Center. That's building 4, the very new building in Osceola, in room 248. So that's the second floor. I have questions here if you're allowed to take the test in a different campus. We do have a couple of people that have special circumstances and that have contacted me and Dr. Pedoni about their circumstances that have gotten special permission, and I'm saying special because if you're not one of those people, if you go to a different campus, they won't let you take it. So anybody that did not get special permission from Dr. Bedoni will have to come to the Osceola campus to take the test on the Osceola campus. So if you have more questions, please type your questions and I will give you an answer.